Hey, hello everybody. This is Newton's Law question, and the question is number 14 off your homework. It's a inclined plane question. You can see my glorious inclined plane shown right here. So anytime you may remember I speak of inclined planes, we're interested in, first off, this tiny triangle that is congruent to the large triangle that has a similar angle. So what I'm going to do is say, well then, if it's 35 in the inclined plane, this must also be 35 degrees. There are several steps that we typically carry out also, which is the FW we're going to solve from the mass. And the weight is always going to end up being mass times gravity. So FW equals mass times gravity. And the mass is 57 kilograms. And we multiply that times 9.8. That's going to get us our weight, which comes out to 558.6 newtons. Now that's what's pulling straight down. That is in fact what I'm highlighting right here in red. That is, of course, this value right here. Now we need to find the parallel force, which is in the direction of the inclined plane, and then the normal force, which is perpendicular to that. And we're going to use sine and cosine in regards to our tiny triangle that we've looked at so far. And so to find out the parallel force, we use sine, because we'll notice that FP is, well, opposite, and the weight is the hypotenuse. So we can say the sine of 35 degrees times the weight, which is 558.6 newtons. And that's going to get us our parallel force, and that parallel force is 320.4. And I'm more or less blindly finding the parallel and the normal force in any inclined plane question. Now, we're going to apply these things in different ways in different situations, but it's always a popular plan of attack. Whereas my normal force, you'll find over time that you do enough of these, normal is typically going to use cosine. The reason being is because, well, we have the normal is the adjacent and the weight is the hypotenuse, and adjacent over hypotenuse, that's cosine. So I'm going to end up saying the cosine of 35 times the weight. And that's going to get us the normal, which is 457.6. Now, let's take a close look at this question overall. It's looking for how much force is required to push this sled up this inclined plane if there's a coefficient of friction. And so the force to push this thing in this particular direction, it's always got to overcome the parallel force, because that's the force that the inclined plane sort of derives straight from gravity. On the other hand, the coefficient of friction is a question of the normal force and the interaction of the sled with its surface. So we have the parallel force, and the parallel force, which is Fp, plus the frictional force, which we call Ff, it's going to equal our total force in this case, which I'm going to say is F total. Now, as soon as we see a coefficient of friction, which is our, well, beloved mu, we should be thinking about the frictional equation. And this friction equation looks something like so. We would say Ff equals mu times Fn. And you'll notice at this stage we have mu because the question shows us mu. Mu, well, here it is, all its glory, right? Highlighted in yellow. And we also have found the normal force through using the cosine over here. So I'm going to take my point 330, and I'm going to multiply that by the normal force, which I calculated out to be 457.6 newtons. And that's going to get me my frictional force. And that frictional force happens to be 137.3. And so now my parallel force, might as well get nifty and change colors one more time for you. Parallel is 320.4 newtons, plus the frictional, which turns out to be 137.3 newtons. And that will give us our grand total, which is shown in the answer, of 471 with sig figs. Hope you enjoyed.